Welcome to the Packages and the Haskell Ecosystem section of Writing Haskell Programs. In this section we will learn about package repositories, searching, including searching repositories for packages and searching packages for symbols, navigating packages, consuming third-party packages, and we'll conclude with a brief tour of popular packages. Welcome to package repositories. In this video we're going to talk about Hackage, Stackage, the local file system as a package repository, and publishing our own packages. Let's first take a look at Hackage. Here we see the homepage for the Haskell programming language at haskell.org. We've seen this before. Now we're going to enter the address for Hackage, and this is at hackage.haskell.org. And Hackage is at a subdomain of haskell.org. Now, Hackage is Haskell's most popular open source package repository and is maintained by the Haskell community. And as we can see here, Hackage is a Haskell community's central archive of open source software. And all code uploaded and stored in Hackage should be licensed with an open source license such as GPL, LGPL, BSD234, MIT, and Apache, and so forth. Here we see it mentions cabal-install and other tools that can be used to download and install packages from the repository. And this includes the stack tool we've been using throughout this course. From this landing page we can browse the packages, we can search for packages, we can look at the most recently uploaded packages, and we can also upload our own packages. Here we see it describes the various bits of metadata that can be included in packages. It also mentions that packages cannot be removed once they've been successfully uploaded. This is an important factor since developers can safely rely on having uninterrupted access to all package dependencies that their projects require. Let's do a search by entering a search term into the search box at the top. Here we go. For example, HTML. Here we see many packages matching this term. These include combinator libraries, and these are typically used to generate HTML documents from templates and so on. Parsing libraries for consuming HTML documents or for extracting content from them. And then various utility libraries for handling encoding of HTML entities, for example. Let's take a look at tag soup. This is a very popular library for parsing and extracting information from HTML or XML documents. Click on the link. Here we see the package metadata as provided by the .cabal file and also the upload history of different versions of the package. It also lists the other packages that this package depends on, in this case base, byte string, containers, and text. And typically below all this metadata we'll see links to documentation. This is the Hackage documentation, typically generated using the stack Hackage command or similar. We can also take a quick look at some documentation. Let's click on text.html.tagsoup. In this page we can look at the various types and functions defined by the package. We also see source links next to each symbol. We click on this source link here. This takes us to nicely formatted and colored source code corresponding to the symbol we clicked on. We can also scroll up and down within the rest of the source file. Up and down. We'll go back. Up here at the top right hand corner we see a source link, which links to the whole source file, contents, which always links back to the contents or metadata page, index, which lists all the functions in the module in a flat format. And we also have contents for this specific page here. Click on index. Here's a list of all the names defined in this package. Let's click on source. See the source code for the whole module. If we return to the top of Hackage, we get our search box back again, and we'll search for another term. We're going to search for the word hidden. And among the other search results, you'll find my hidden char library, which is right here. This one's one of mine. Scroll down to the downloads section, and here you have a direct link to the tarball containing the source code for the package. You can also click Browse to look directly at the source files in the package. And here's one source file, posix.hs. This has the POSIX implementation of the getHiddenChar function. We'll return to the home again. If we click on the Browse button, we can view packages grouped by category. So if you're looking for database-related items, for example, you can click on the database category, which is right here. You'll see there are many packages in this category. At the time of the recording, Hackage contains about 12,000 Haskell packages in total. Now note that quality and compatibility can vary a fair deal. Furthermore, not every package has been tested for compatibility alongside every other package or with every version of GHC. Fortunately, it's almost always the case that if the package can be successfully downloaded and compiled in the context of your project, then it will work as advised, unlike packages for dynamic languages where all errors are deferred to runtime. This is one of the many advantages of a strong, statically typed programming language like Haskell. This brings us to the second popular source of Haskell packages, namely Stackage. This is at stackage.org. Go. The name Stackage is a portmanteau of the words stable and Hackage, and this is described here. Stackage is a stable source of Haskell packages. And essentially, Stackage is a curated subset of all the packages available in Hackage. And these are sets of packages that are guaranteed to build together and pass tests with one another. The maintainers of Stackage build nightly package sets, and these are what we'd consider cutting edge, compared with stable or long-term support package sets, LTS Haskell. And this is what the LTS 7.8 resolver that we've used throughout this course corresponds to. Now you'll see that LTS 7.8 isn't currently listed here. That's because that's not the most recent LTS 7 snapshot. So we'll click on the nearest, which is LTS 7.20. That takes us to the landing page for LTS Haskell 7.20. We can even be a little bit sneaky here and edit the URL, point to 7.8. And here we see that this LTS snapshot contains a subset consisting of almost 2,000 of Hackage's 12,000 packages. In general, if we use the stack build tool and a snapshot like this, we can have high confidence that projects that depend on these packages will build consistently and continue to build for the foreseeable future. Let's take a quick look at one of them. Here's AWS-0.14.1, which is an Amazon Web Services package. Here's the landing page for it. This page shows various pieces of Stackage metadata associated with the package, including author and snapshot information. Here's the author and license. Here's the various snapshot information. We also get the documentation, much like we do in Hackage. We also see links back to Hackage. So up here we have 0.16. That takes us to Hackage. Click on the Home button to go back to the top. You see we also have a search box up here. Unlike the Hackage search, this search uses the Google search engine. And this allows us to search by type signature as well as by function name or package name. For now, let's just search for map, M-A-P, enter. And this finds map, as we'd expect. We'll look much more at searching later on. As we'll also see later, our stack-based Haskell projects can easily consume packages from both Hackage and Stackage repositories using a combination of the Cabal file and the stack.yaml configuration file. It's also straightforward to reference packages off the local file system. And this is ideal for an iterative development process where we're developing a new package alongside an application that depends on it. A local package will often be another package that we're developing as part of a common parent project. And let's take a quick look at a couple of example projects that demonstrate these three approaches taken together. Here are our two projects. We'll look at local-package to start with. And here's the stack.yaml file with our trusty LTS-7.8 resolver. Here's our project's Cabal file that exposes a single module in the library target. The module is named local package. If we open the source file for local package, we see that it exports one function, local package func, where local package func is putstrlen local package func. Meanwhile, here's the other project example which depends on that. Here's the stack.yaml. Again, we're using the LTS 7.8 resolver. In this configuration file, however, we're specifying multiple package directories. This is using the packages value. We're referencing the current directory, which is the default in the absence of a package's value, and we're also referencing the local package directory, which is the directory containing the local package project here. We've also added what's known as an extra dependency. This is in the extra deps section, and the extra dependency is blockhash-0.1.0.0. And this is how we reference packages that are not part of the resolver specified at the top of the stack.yaml file. It's the name of the package and its full version number, separated by a dash. And blockhash is a perceptual hash library, and this can be used to compute the similarity of images, for example. And this is just an example. I just chose this package because I've used it from time to time and it happens to be absent from Stackage long-term support snapshots, but it's readily available from Hackage. Here's the Cabal file, and we see a single executable target named example, and it has 4 dependencies specified via build-depends. And these are namely base and vector, which are both from the LTS 7.8 snapshot, local package, which comes off disk, and then block hash, which is what we've referenced via the stack package indices, but which is taken from Hackage by default. Finally, we have the source file. We import from data.blockhash. We import from data.vector_unboxed, qualified as vector. We import from local package. We define 2 hashes. We use the hash data constructor constructed from a list of chars. We construct a hash computed from a vector of chars, and a second hash computed from another vector of chars. In the main function, we evaluate local package func, and we calculate the Hamming distance between 2 hashes. Let's build that and see what happens. cd into example, and we'll run stack build. Now that's complete, we can run the program, stack exec example. Scroll down the source file to see if that makes sense. Local package func, and the Hamming distance is 1. And given that the hashes are 0, 1, 2, 3, 4 and 0, 1, 2, 3, 5, that seems like a sensible Hamming distance. Finally, Stack supports creating and publishing packages. So let's consider our example project. Once we finish writing the code, we can create a source distribution using the sdist command we've seen briefly before. Let's do that. Stack sdist. Now notice how this command generates source distributions for both the package and any non-dependency packages it depends on. In this case, example and local package. Now we'll take another look at the Hackage website to look at how to upload packages, given that we now have a source distribution tarball. So we'll go back to Hackage. Click on the upload link. And these paragraphs explain uploading, source distributions, licenses, and so forth. And we can click on this upload package link. This would allow us to upload the source distribution file directly from this form, directly from disk. We'll go back and we'll scroll down a little bit more. And we see this package candidates section. Package candidates is a mechanism that allows us to upload packages for test purposes only. This is very useful for evaluating whether your package is valid or not. Now, we've already talked briefly about the stack upload command for automatically uploading source distributions to Hackage. Running stack upload is equivalent to uploading from this upload package link up here. For demo purposes, however, we don't want to publish this as a final package since we can't revoke that at a later time. We prefer to upload it as a candidate. And indeed, we can do it from this form using this link here. And Stack, unfortunately, does not currently offer a variant of its upload command that will upload a candidate only. The underlying Cabal library does support this, but for now we'll upload it as candidate from the form. So we'll click this link here, upload a package candidate. We'll click on Browse to find our file. Have a shortcut to it here. Stack work, dist, it's hash code, example-0.1.0.0.tar.gz. Double click on that, click Upload Candidate. At this point we'll be asked for our credentials to log in. So I already have an account. That's my username. It's my super top secret password. And there we go. The package has been uploaded for us. And at this point, we can change the status of the package by scrolling down and clicking on Edit Package Information. And this link would allow us to promote this package to being a full-blown package using the Publish Package link, and to change other aspects of the package. But for now, we're just going to delete it. There we go. It's not found anymore. That's great.